Hi, this is Jim Brickley of Conventus Polymers. In today's Fast Class series, I'm going to speak about a very simple topic of comparing datasheets. Here is a simple datasheet comparison of two resins. You can get this from various resin suppliers and try to line them up. You can also get them in from third-party software systems, like shown here, that'll nicely compare them side by side. The resin on the left in green and the second resin on the right in light gray. If you look at the first line item of density, you can see that one value is 1.04, one value is 1.20, and those were done with an ASTM test. The problem is, as you go down this list, like melt flow rate, shrinkage, modulus, strength, elongation, you will see that they just don't line up as well. You can see that the melt flow rate was 5.6 and the other one was 18. However, if you look closer, the one was done in a melt flow indexer with 230 C of temperature with a 3.8 kilogram weight pressing that plastic through a small orifice. With that ASTM test, you did get 5. But if you look at the other resin, it was done at a hotter temperature of 300 degrees with a lighter weight of 1.2, but it had a flow of 18. And the third number, 220 C, with a much larger weight of 10 kg, it was 18. But wait, that was done with an ISO test method instead of an ASTM. So it can get quite confusing. And as you go down through this list, some things line up and some things don't. Some things have little footnotes like 3 and 4 to read. You'll see some things you think line up, but again, the test methods are different, and so on and so on. So it can be quite confusing. So let's just focus on one piece of the data sheet. And again, these all have very complex ways to look at the different properties. The first one would be some lab methods. We could take this machine. This is a standard MFI tester. You add a bit of plastic, you put some weight, and you push it through the hole and measure how many grams in 10 minutes. We could actually do that. We could send both resins to the lab, and we could do them at the same temperature and get a feel for how the two resins compare. There's also more advanced methods, like capillary rheometer. These curves will show you as you increase the shear rate closer to actual injection molding shear rates, how the two materials react. There's also, quite advanced in the last few years, machine rheology techniques, where custom molds have been built. You can change thicknesses, you can change speeds, you can change the melt temp, and you can see how that material flows in an actual injection molding machine. But it's on a test mold, which is typically like a sample bag. So in this particular case of comparing flow, the question really is, how do the materials flow in my part design? There's a couple ways to do that, and these are just two that come to mind. Is one, some people build a mold. They simply build a prototype mold. They throw a gate and runner on it, and they inject it, and they get a part back. Rarely they get much about the flow, but they will get back, hey, it worked, and you have a part. There's a lot of positives and negatives to that. But another way that we like to use is a simple computer simulation of how the material is going to fill your actual part, like shown here on the mold flow analysis on the bottom left. So this is a very simple simulation. We do it at no cost, and it's just to see if we added a gate to the part, how would it fill? What would the pressures be? How can we compare those two different resins we saw on the datasheet? Now, this is simple. This does not include a gate and its size. This does not include a runner. But it'll still give you an apples to apples comparison of these two resins giving the same gate and how they fill, and mainly what the pressure is to fill. So on the left, you have the resin that takes 10,000 psi to fill. And on the right, you have a resin. It took 22,500 psi to fill. Obviously, not every machine can do that. And again, we're not including the other pressure drop items like gates and runners and machine nozzles. So once you get this really rough idea of how these two resins will flow in your part, we can make some changes. And often it could be we might want a higher flow resin. We might need to use 2 gates or 3 gates, but we might have weld lines in critical locations, etc., etc., etc. It's quite complex beyond that point, but we have answered with pretty good confidence, will it fill your part, which I think is much better than the MFI I showed on the data sheets. So what changes should you make? Well, Conventus, we have a large group of plastics engineers. We added up the experience, and it's over 300 years of plastics engineering, seeing problems and solving problems. So, in short, we're here to help. Please contact us, and we can dig into this further. I'll leave you today with a list of some of the material options we have here at Conventus. It's quite a complex list, but we are here to help you pick the proper resin for your application and based on what it needs to do, including flow, heat deflection temperature, chemical resistance, and a lot of the other things to consider when picking a resin and digging further than just what you see on a datasheet. Thank you very much and have a great day.